To welcome all students enrolled in this analog communication 1 course. In this lecture, I will explain what is amplitude modulation. Then I will explain how physically signal is getting changed in amplitude modulation. Also, we will derive basic equations which are very helpful based in amplitude modulation. Then, at the end, I will sum up this lecture by frequency response, which is there by amplitude modulated signal. So let us begin this lecture with basic amplitude modulation. So first of all, what is amplitude modulation? Amplitude modulation is a process of changing the amplitude of a high-frequency carrier signal in proportion with the instantaneous value of modulating signal, which is a message signal that carries the information. Or another definition, it is the process in which the amplitude of a carrier signal changes with respect to message signal or the modulating signal. Also, we have many other definitions. Amplitude modulation is a type of modulation where the amplitude, the signal strength of the carrier signal, is varied in accordance with the amplitude of the message signal. Okay, so if we consider a modulating signal as shown in figure A, that consists of a single frequency component. This signal has information and it has a low frequency component, FM. The amplitude of the message signal is AM. So the message signal or the modulating signal is varying between plus AM and minus AM. And this, as we said, this signal carries the information. Another signal, which is a sinusoidal wave, has an amplitude of AC and frequency FC. This signal has a much higher frequency than the message signal. So the carrier signal has much frequency, higher frequency than the message signal. So modulations in amplitude modulation technique is varying one of the characteristics of the carrier signal, whether to change or modify the amplitude, and in this case we call it amplitude modulation, or we change or modify the frequency, and in this case we call this technique is frequency modulation, or we change the phase of the carrier signal, and this we call it the phase modulation. So here we are going to explain about the amplitude modulation, where the amplitude of the carrier signal will be modified or changed in accordance with the message signal, while we keep the frequency and phase constant. So we change only the amplitude and we keep the frequency and phase constant. So the resultant signal, we call it the amplitude modulation techniques, and the resultant signal is called the modulated signal. As shown here in this figure, figure C, the modulated wave or modulated signal, and it is given by S of t equal to AC 1 plus mu cosine omega mt cosine omega ct. This signal, the modulated signal, has the same frequency as the carrier signal. So the modulated signal has the same frequency as the carrier signal. And here we found that the envelope or the amplitude of the carrier signal has been changed in accordance with the message signal. So here we have the envelope of the message signal, and this signal can be derived using the following mathematical equation. So we have m of t is equal to am cosine omega mt, and s of t, as the definition states, that the amplitude of the carrier is changed in accordance with the message signal, which has the information. So the amplitude of the carrier will be changed in accordance with the message signal. So if we state that s of t is equal to s a dash cosine omega ct, so we change only the amplitude of the carrier, while we keep the frequency and the phase constant. So a dash now will be AC, which is the carrier frequency. This is a carrier frequency, amplitude of the carrier frequency, AC, will be changed in accordance with the message signal, m of t, with the instantaneous value of the message signal. So AC will be varying with the message signal. This is a message signal here in time domain. So the information is buried in the envelope of the modulated wave. And as we said that the carrier signal has no information. So here S of t, the modulated wave, will be equal to AC plus m of t into cosine omega ct. So if we substitute the value of the message signal m of t, which is equal to am cosine omega mt, the resultant equation will be AC plus, instead of m of t, we will substitute am cosine omega mt into cosine omega ct. So only the envelope will be modified as the process states. So here we have AC plus am cosine omega mt into cosine omega ct. So if we take AC as a common factor from this equation, we will have AC bracket 1 plus am divided by AC cosine omega mt cosine omega ct. So if we multiply AC inside, we will have AC plus AC times AM over AC. AC and AC will be cancelled. We will be left with AM cosine omega mt. So we take AC as a common factor, which is the amplitude of the carrier, and we will be left with 1 plus AM over AC cosine omega mt into cosine omega ct. AM over AC, we call it mu, which is the modulating index. This is a modulating index and is given by the maximum amplitude of the message signal divided by the maximum value of the carrier signal. So S of t will be equal to AC brackets 1 plus mu cosine omega mt, close the brackets, into cosine omega ct. So this equation, we call it the modulated wave. This message or this equation, we call it the modulated wave or modulated signal that can be transmitted at the transmitter, and this signal will be propagated in the channel, and at the receiving end we do a process called demodulation to extract the message signal from the modulated wave. Because this equation states that the signal S of t is equal to AC 1 plus mu cosine omega mt into cosine omega ct. So at the receiving end, we extract the message signal from the modulated wave, and this is done by what we call it demodulation. So modulation process will be achieved at the transmitter side, and the demodulation will be done at the receiving side. So the corresponding amplitude modulation waves is there given by, as we said, S of t is equal to AC 1 plus mu, which is the modulating index, cosine omega mt into cosine omega ct. If we expand this equation, we will have AC cosine omega ct plus AC multiplied by mu into cosine omega mt into cosine omega ct. So cosine, we can use this expression or this equation to simplify this expression here. So cosine A, cosine B is equal to half cosine the summation of the two angles plus cosine the difference between the two angles. So we will have S of t is equal to AC cosine omega ct plus mu AC over 2 cosine the summation of cos omega m and omega c plus omega m t plus mu AC over 2 cosine the difference between omega c and omega m, omega c minus omega m t. So in this equation, we will have three frequency components. One is a pure carrier signal frequency component, which is omega c, and we have two frequencies, omega c plus omega m and omega c minus omega m. Omega c minus omega m, this will be called the LSB, or the lower sideband frequency. And omega c plus omega m is called the upper sideband frequency, or USB. So both of them, we call them the double sideband frequencies, double sideband. So we have three components. This is a pure carrier, which has no information. So the information only exists in the upper sideband and lower sideband. Thank you.